So there's nothing special about this problem other than to remind us if when we solve, we end up with a radical in the denominator of a solution, we need to rationalize the denominator. The process other than that is exactly the same. So we start off with 5r squared minus 2 equals 34. We'll add 2 to both sides, which gives us 5r squared equals 36. Divide both sides by 5, and we get r squared equals 36 divided by 5. So now we invoke the square root property, plus or minus r equals, square root of 36 is just 6, but we're left with the square root of 5 in our denominator. So how do we rationalize that? Well, let's multiply by what gets rid of the square root of 5. Since it's a square root, the index is 2, we only need to multiply it by one other square root of 5. So rationalizing the denominator, we end up with plus or minus 6 times the square root of 5 over square root of 5 times the square root of 5 is just 5. Which essentially means, if we wanted to write it out, x equals the negative 6 times the square root of 5 divided by 5, or x equals 6 times the square root of 5 divided by 5. In most instances, you can just leave it as r equals plus or minus 6 times the square root of 5 divided by 5. Both of these things are saying the same thing. So we'll check our solution. The variable term is only being squared. It doesn't appear to the first power, so we know that if we check the negative, it's going to be the same for the positive. So let's take our 5 times r, negative 6 times the square root of 5 divided by 5. That's being squared. Minus 2, we want to know, does that equal 34? So 5 times negative 6 squared is going to be 36. Square root of 5 squared is going to be 5. And then 5 squared is 25. And again, minus 2, we want to know, does that equal 34? Well, we can cancel the 5 here and change the 25 to simply a 5, because 25 divided by 5 is 5. And then if we'll notice, we're multiplying by 5 on the outside, so the 5 will cancel with the 5 that's left in the denominator, leaving us with 36 minus 2 does indeed equal 34, so our solution checks. And in this case, since the variable is only being squared, it doesn't just appear as r anywhere in the equation. We know that if we simply change this negative that we substituted to a positive, the rest of the steps will be the same. Verifying that 5r squared minus 2 equals 34 when r equals plus or minus 6 times the square root of 5 divided by 5.